Hello and welcome to day 11 of my Advent of Code series for the year 2020. If you've missed any of the previous episodes and you want to check those out, check out the Advent of Code playlist linked right up here. And be sure to get subscribed to my channel and turn on post notifications so you don't miss any of my future videos doing Advent of Code or in any of my other series. So today we have day 11 called Seating System, and the idea here is we have landed from our plane, we are now trying to board a ferry, and we are waiting in this waiting area, which has a seat layout like this. So the deal here is that L's are empty seats, pound symbols are filled seats, and dots are the floor. And the way that we know pretty much on each cycle until it stabilizes, the seating pattern will change like this. If a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. And if it's occupied and four or more seats adjacent to it are also occupied, then it becomes empty. And otherwise, it stays the same, and also the floor never changes. So you'll see here it works through an example. In this initial example, all of them will become occupied, and then it'll go to this, and then this, and eventually it will stabilize here. And at that point, we want to count how many of the seats are still filled at the end. So the thing here, if you go ahead and try this out right now, if you don't know where to start, I recommend looking up Conway's Game of Life, because this is a simplified version of that. It's actually more complicated in some aspects, I guess, because there are 3 different kinds of cells instead of just 2. But go ahead and check that out if you need somewhere to start. Be sure to try this out for yourself, and then we're going to jump into my code right about now. So the first thing that I do here is in my readGrid function, I am reading it in as a list, and I'm also mapping all of the strings to be lists. So technically you wouldn't have to do this if you were just accessing it, but I mutate this grid directly, so it's easier for me to just have it as a list. And then the way that I broke this down is into 2 separate functions. One called run, which takes in a grid, a check function, which is what we're going to use, and a tolerance. So the reason it's laid out like this is actually just so I could use the exact same code for part 2. Technically, I had this all in my part 1 before, but then I broke it out. So what we're doing here is while true, because I'm going to return in this loop, so I don't need to have any sort of stopping condition for it. I initialize 2 grids called to fill and to empty, and the reason I do that instead of updating the board directly every single time is because all of these changes have to happen simultaneously. So if I mutate the grid, then it's going to change what the check is going to be like for another seat, which is not what we want. So then what I do is I loop through our entire 2D grid here by having an outer loop that's going to get every list in our list, and then an inner loop that's going to get every item in each of those lists for those indices. So then I just set whatever our current is to whatever it is. If it is a floor space, then I just continue because we're not going to update it in any case. And if it is not, then I get a count of how many of the things are adjacent to it using the check function that gets passed in. So you'll see here in part 1, the check function that gets passed in is check adjacent, check adj right here. So what we do here is we initialize a count, and then I am looping through all of the seats that are around the seat that we're looking at, and I have some bounds here. So the first thing is going to go from I minus 1 to something, but the thing is, if I minus 1 is a negative value, this map doesn't wrap around. So we want to say if it is in fact off the grid, then we'll just do that as 0 instead. And that's going to loop to the minimum value between the length of the array and I plus 2, because we want to go 1 over to the right, and bounds are not inclusive. But if it is in fact off the board, then we just want to use the length of the grid instead, so that we aren't going to go out of bounds. So then for x, you'll see we're doing the same thing, but with the other dimension, working with that. And then since I did this in a loop like this, instead of initializing a list of all the different directions or something like this for this part, I just thought this was a little bit more elegant. What I do is if I need to make sure that 0, 0 is not going to be something we check, that's the seat that we're currently at, or not 0, 0 really, but moving 0, 0 from our seat that we're checking. So I make sure that y and x, which are the values that I'm looping through here, do not equal I and j on each run, because that will just be the seat that we're actually checking. It's not adjacent to itself. So then also, if the seat that we're checking adjacent to has a pound symbol, so it's filled, then we increment our count, and at the end of that, we return our count. So then once we have that adjacent count right here, what we do is if the current seat is empty and it has 0 seats adjacent to it, then that's the case where we need to fill that seat. So I put its coordinates into the toFill array. But if it's already filled and it's greater than or equal to tolerance, which in part 1 is 4, then I put it into to empty. So then what I do is I loop through, once we run through every single coordinate, I loop through to fill and switch all of those seats to be full, and then I loop through to empty and switch all of those seats to be empty. But if to fill and to empty are both empty themselves, that means that we've hit a stable state, and in that case, we need to return the count of how many seats are filled. So the way that I do this is I map a count of all of the pound symbols onto each list, and then I just get the sum of that, and that will give us the number of seats that are filled overall. So that's it for part one. I think it's a pretty straightforward solution overall. And then moving on to part two, we have part two, and we notice that people's behavior is slightly different than we expected. So instead of looking at the seats directly adjacent to them, they look at the seats in their sight line for each of the 8 directions. So that's up, down, left, right, diagonal, and all the diagonals. So it gives some examples of how that might be very different from what we were doing before. And so pretty much they check the first seat that they can see in each of those directions instead of checking the seats that are adjacent to them. So if the first seat they see is empty, then it doesn't get added to the count, but if the first seat that they see is actually filled, then that does get added to the count. Also, we noticed that they're more tolerant than we expected, and they can see 5 in every sight line and still not change rather than 4. So I recommend you go ahead and give this a try. If you did the first part like I did, breaking it out into a separate function, then this is pretty easy. If not, you can go ahead and do that, I think, relatively easily. And we're going to jump into my code once you're ready for that right now. Okay, so we're going to use that exact same run function, so that same explanation that I just used is going to apply, except for what we do in this check function is different. So we're just going to go over that. So what I did for that is I wrote a separate function called checkVis. You'll see here in part 2, I'm just running that same run function with the grid checkVis and 5. One thing to note here is that I did use a deep copy of the array for part 1, because otherwise if you just try to run with that same array in part 2, you're going to get whatever the stable state from part 1 is as your input instead of the actual starting array that you want. There would be other ways to do this. Obviously, you could copy it inside of part 1 or part 2, or have both of these be copies so it's similar, but whatever, it doesn't matter. This is just to ensure that we're working on the same grid for both times. Because I did have an issue with that at first and didn't realize. So for checkVis, what we do is I initialize this constant array right here, which just holds a bunch of, or this constant list right here with a bunch of tuples that represent each of the directions we have to go. So we can go 1 in either the up or down direction or -1. So 1 in the up or down direction, -1 in the -1 is going down. This is going right. This is going left. This is going up and to the right. This is going down and to the right, whatever. These are all the different directions. You'll see it's just the 8 things that you would expect. It's the 8 adjacent directions. So what we do in checkVis is the same as before, I initialize a count is 0. I loop through all of these directions. I say that the current thing is whatever we're checking, and current is just a list of 2 elements that has I, which we're passing in. That's the element that we're actually checking, and we're adding the first part of our DIRS thing to it, and then J, we're adding the second part of our DIRS thing to it, and then I start a thing here called found, which starts as false, and our loop here says while current is in the bounds of our array for both of the directions, for both of the dimensions, and found is not true yet, then we go ahead and do this. So what we do is we find the current value at whatever the coordinates in our cur variable are. If that seat is filled, then we go ahead and add 1. If it is, and then we say that this is found, so we'll move on to the next direction. If it is empty, then we just move on to the next direction without adding 1, and otherwise we increment it again, so that we'll check through this loop again. So if you think about it like this, if you had a grid right here, let's just, okay, yeah, you know what, let's just look at one of the fake grids. That's a much better idea. So if we take a look at this right here, right? So let's say we're checking this empty seat right here. So for each of the directions, we're going to check up and we're going to go out of bounds. We're not going to get a count. We're going to check down. We're going to go out of bounds. We're not going to get anything. We're going to go left. We're going to go out of bounds and we're not going to get anything. We're going to go right and we're going to find this empty seat. Okay, so then on that empty seat, what we do is we increment again, and then on the next one, we find this that floor space, and then on the next one, we find this empty seat. So then that's what we get. And then going in each of the diagonal directions, we'll eventually just hit the outside bounds. So that's how we're checking our sight lines. We just use that as our check function part 2 and pass 5 as our tolerance. So then if we go back to look at how our run function worked, you'll see since we're just using check here, it's going to use whatever function we pass in. And since we're just using tolerance here, it's going to check against whatever tolerance we put. And that's how I solved part 2 using the pretty much exact same code for part 1 except for one other function. And that's pretty much it. So I hope you enjoyed the video. Be sure to leave it a like if it helped. Comment down below if you had a different method or if you have any optimizations that you want to discuss. And I will see you in the next one. Be sure to get subscribed. Check out the playlist if you missed any of those. And I will see you next time. Goodbye.